Hi, I'm Roel Rosol and I work for Howland Research Forest, and we are located in Maine in the United States. And I will show you in this video our usual workflow for processing our raw flux data from an eddy covariance system using EddyPro and the output, its full output, and how we prepare it for data cleaning and QA/QC and gap filling and partitioning. So let's start. So first of all, we need to open up EddyPro, right? So when you open EddyPro, it will greet you with this. So first thing is to go to project creation and you type in your name of the project. So here let's say I'm processing Howland data and I'm processing it on October 10, 2025. So this video is for sites that do not have the raw file format in the Lycor native file. So if you have a full Lycor system, you will see there's a GHG file in each of the folders when you collect your data right from your system. So that's very handy if you are using EddyPro, because it will automatically acknowledge, or it won't then have a hard time reading your raw files, your metadata here, and even your biomet data, because they're all in the same folder. So I hope Lycor covered that in their tutorial during this workshop. But for this video is for sites that, like us, we collect data and we compile them as CSV files. So to do that, first we need to select this option here, the ASCII plain text. So you can then use CSV files to run EddyPro. Next thing would be to upload the metadata. So metadata in EddyPro is like basically the settings that EddyPro will look, so that you will essentially guide EddyPro on how to handle your data. So in the first tab of the metadata file, you can see that there's station. So for this section, you just input details from your station. If you're collecting and naming your raw flux files as the beginning of the data set period, then you should just click this option. So this is what a usual CSV file looks like for the raw flux files. So you have your station name and the timestamp. So here we're following the year, month, day, hour, and minute format. So this essentially tells us that this first file contains 30-minute data from May 1 midnight until May 1 0:30 a.m. So if I open this file, it will show us this. And then it will show you the different columns. And then at the bottom, it ends at 12:30 a.m. So this is a usual chunk of metadata per or usual content of one raw file for eddy covariance. So it usually is divided into 30 minutes. So that's why also you can see here that the file duration is every 30 minutes. Acquisition frequency, we acquire data every 10 times a second, or 10 hertz. So you can see that in the raw flux files. So every second we have 10 measurements, so 0.1 every 0.1 seconds. So again, that might vary depending on your site. If you have a 5 hertz, you just put in here 5 hertz. If you have more than 10 hertz, you put it more than 10 hertz. And then canopy height, again, depends on your site, the displacement height, roughness length. If you don't know how to get it or how to know for your site, the good thing about EddyPro is that if you click on this like question marks, it will pop up a window and it will tell you the formula. For example, here, displacement is 0.67 times canopy height. So you don't get lost on setting up your metadata. Instrument section, so it will ask you to what are the components of your system. So left here is the anemometer, so the sonic anemometer that measures the wind variables, right? So it contains the usual models, so Campbell Scientific usually if you have one, oh, and then you just populate it with whatever anemometer you have. And then of course the height is important, like how high it is from the ground. And then the gas analyzer here, which measures the concentration of your gases. So put in here the model of your gas analyzer, and then if it's a closed path or you just put in the tube length, and then the diameter of the tube, etc., etc. Again, I'm assuming that you have already know how to set up a metadata. So we're just going kind of like fast on this one. And then for the raw file description, so this setting essentially tells EddyPro what is in your raw files, right? So in our raw file, we have 17 columns, and all of the columns actually we don't need. Our site has been running for like 30 years, so we have like several sonic anemometers and several gas analyzers. So you can see here there's actually a lot of columns. So if I don't want to use, like for example here, this gas analyzer here, it's not been working for a couple of weeks now, I can omit that in the data processing. So let's look at what a populated metadata looks like. So for our site, it looks something like this. Station information, instruments, we have the sonic anemometer. On the right, we have the 3 gas analyzers and their information. Another important thing also is the separation of your gas analyzer to the sonic anemometer. Again, it will just ask you how it is separated northward, eastward, and vertical separation. So those are very important because it needs that information to determine an accurate estimate of your fluxes. Because if they're separated for a good distance, there's a lag between when the sonic anemometer measures the wind, the vertical wind speed, versus the measurement of the gas analyzer with its gas concentration. So this is also an important part of the metadata. For the raw file description, so once you start populating this, you would just tell, for example, the second column is a sonic measurement for U, third column is sonic measurement for V, etc., etc., etc. If you don't want to include the column in your in your processing, you can just like select the first option and then put yes on it. So it will essentially tell EddyPro to ignore that column. And then the final part for this section is the biomet. So the biomet data contains biometeorological data that is important for running EddyPro. So for us, we have 3 variables that we feed in EddyPro in the biomet file. So the biomet file should contain average air pressure. These are the minimum variables required by EddyPro. Air pressure, air temperature, and relative humidity. So the average every 30 minutes for the duration of the file that you're processing. And this is again in CSV format. And once you have that, you just populate it here. For the basic settings, first it will ask you the data directory. So one thing, if you're doing it for the first time, once you select that folder, it will ask you the format of your raw files. So our raw files is named as, again, this could be anything, but the important thing is the years, month, day, and hour arrangement. So we are doing year, month, day, hour, and minute. So once you have that, click OK. And then if you click detect data sets, it will actually tell you if you name it correctly and you input the format correctly, it will tell you which period it detected in that folder. And then the output directory where you want your output is and your output ID. You don't have to do anything here on the right, except if you want your wind direction to be referring to magnetic north or geographic north. If you're one geographic north, then you need to know the magnetic declination of your site. Here at the lower half, so it will ask you to select the sonic anemometer. Again, if you set up the metadata correctly, it will show up the sonic anemometer, the gas analyzers, and then the biomet columns here. It will just ask you where is the temperature, pressure, and humidity in your biomet column. So this part is usually where EddyPro fails, right? So if you don't set up the metadata correctly, if the naming format is different than what you put in here, if you don't put a correct biomet file, this is usually the culprit for a failed EddyPro run. But once you have this set up correctly, you can actually do express mode. So express modes just runs all the default settings for EddyPro. And what are those default settings? If you go to their website, it will, and then search for this, it will tell you all of the settings that they did for your run. So this is the default settings, and we'll kind of like browse into this a little bit longer later. So I do encourage and recommend that you do an express mode run first if you're doing it for the first time, just to see if it's gonna run correctly. And just to know, just to see if the metadata, your raw file format, and all of your settings are correct. It might not give you a very accurate estimate of the fluxes, but at least you know that once your express mode is running correctly, then you can go ahead and do the advanced mode. So for the advanced setting, this just gives us more freedom to change how we filter the raw data before it gets processed, what kind of like corrections we need or we want for our fluxes. So stuff like that. We're not gonna dig or dive really deep into this one, but we're just gonna browse on them really quickly. So for the first option, processing options, so this will ask you what kind of like correction you want to do for your sonic anemometer values or variables. Because sometimes, the sonic anemometer could be, there might be a lot of like vibrations in the tower, or like it's not correctly angled. So it could correct, this setting can correct for those tilts and pitch of the sonic anemometer if they're not correctly, or that if they're not perfectly set up. Here also, there's a time lag detection method. This is important, especially for enclosed or closed path gas analyzers, because there's a lag between when those, gas concentrations travel to those tubes. So the usual setting is covariance maximization, but also automatic time lag optimization is a good for first run. And if you have an open path analyzer, you need to check this setting to compensate for density fluctuation. So this just has something to do with the heating of the sampling cell when you have an open path. If you have a closed path, you actually shouldn't check this one. And it's also just good to output statistics. So quality check and footprint estimation is here. Statistical analysis, you don't actually have to tweak anything here. The default setting is good enough. So it essentially, this is just for screening the raw data before it can be processed. And then random uncertainty estimation is also good, just to have an estimate of the random uncertainty in your data. Spectral analysis and correction. So this is a little bit complicated, but to sum it up, when we're processing flux data, some of the signals are lost, especially if they are coming from a low frequency and high frequency. So the spectral correction essentially is trying to find an equation where it tries to recover those lost signals from the high frequency and low frequency ranges. So in this section here, you actually have 5 options. The default runs Moncrief, but based on like several studies, this, depending on the correction, the spectral correction options that you choose, it will actually lower or increase your fluxes. Not a lot, but not by a lot, but it will still impact your overall estimates. So this is something that you can like explore on your site once you try to do your advanced setting. And then for the output files, one good thing about EddyPro is that it could output a FLUXNet standard file, and we'll look at that later. Always check the full output files. Also this, use the standard output, and then this continuous data set, because it will just give you all of the timestamps for the given period, even though we don't have any, if you have any missing fluxes for that period, it will still show up, and it will just, set as missing values. All right. So here I'm actually running 1 month of data. And if EddyPro is learning correctly, it will show up as something like this. So it will start processing. It depends on the processing period, depends on how much data you have, how much data you feed it, and also the processing speed of your computer. But once this is done, you should see something like EddyPro successfully process your data. And if there's an error, you would see it here. Again, I've been running this for like maybe, you see here, an hour now. This is like about 3 months of data. So we're not gonna finish this. We're not gonna wait for this to finish. But this is what you will usually see when you're running the data. And then for the full output file, once this is done, you will see something like this. So this is the output folder. So you have your EddyPro project file here that you used. And then if you look at the full output file, it essentially contains so many information. You can delete the first and the third column because we actually don't need that. I mean, depends on you, but I usually delete that because I already know the units. But this column contains the variable names, and then this column contains the units. So really, there's a lot of information here that you can use to clean your data. We usually use like the variance of CO2 and also like the variance for like several wind variables to filter our data. But it really depends on you. Like each site has a different cleaning protocol. But let me just show you what it looks like once we have this output file. So one thing also with EddyPro output files that the NA values are -9999. So if you're using R or like other softwares, just be careful and just like tell it to set NA values to -9999. If not, it will mess up your calculations. So yeah, so an EddyPro output really has like over 180 columns here, as you can see, and it has almost every information that you need to really clean this data and for gap filling, essentially. But then I want to show you, this is the CO2 flux that hasn't been cleaned or what we call a post-processed. So this is just the output from EddyPro. As you can see here, there are gaps. There's a gap here. And this is just showing the big gaps. But within these days, if we zoom in, it might be possible that there are also gaps within a day. So from this process file, what we'll do next here is to do a post-processing, which is the cleaning. And then after cleaning, we just use the columns or variables that we need for gap filling and partitioning. And I believe Mo would cover that. But here I just want to again highlight to you why we need to clean the data first before feeding it in a gap filling and a partitioning processing. So for example, here you have an obvious outlier here. This could be an obvious outlier here. If we look at um, H, LE, our energy fluxes, we can also look at H2O fluxes, or maybe not. And then date of year. So here, you also see that there's already like all these outliers, right? So this one's outlier here. So here it's up to you to determine if is this actual is this signal or is this noise? Like what happened here in this part? Is this the gas analyzer failing, or is this an actual like signal from the environment? So this is really up to you to clean. So with the gaps from the output using EddyPro, there would still be gaps after you clean it, or what we call it the post-processing period. So those gaps need to be filled. And that's why we're using, tools like our EddyPro to gap those, or to fill those gaps. And once those gaps are filled, then we can partition the net ecosystem exchange to GPP, gross primary productivity, and ecosystem respiration. So that is it for this part. If you have any questions, I will be hanging around during this period. But I encourage you to play around with EddyPro using your own data set. And also like just start with the express mode. So again, if you have any questions, I'm very willing to help you set up your EddyPro runs for today. Thank you.